Welcome guys, as we do yet another problem right here. I read the question, determine the eigenvalues and eigenvectors of. Guys, we have a matrix here which is A equals to, we have the first row that is 3, 2, 2, the second row 3, negative 4, negative 2, and finally 0, 5, and 3. Guys, now we start off with this question. The first thing, guys, we are going to establish is the characteristic equation of finding the eigenvalues. And our characteristic equation, guys, is A minus, this is the eigenvalues, that is alpha, phi, not alpha but lambda, and identity. Guys, now this, when you look for the determinant is supposed to give you 0, and this is what I have done right here. As you can see, you see my matrix is right here, 3, 2, 2, all that minus lambda multiplied by the identity matrix. Remember, the identity matrix has 1 right here, even here is 1, and even here is 1. So when we multiply by lambda, this is what you get. And now when you do that, when you subtract this from this, guys, you get this as our matrix, which we need to look for the determinant. And the determinant, guys, as we can see in our equation, it's supposed to give us 0. Guys, now we take the first row. Taking the first row, guys, we are going to have to cover this row and this column. And so now we deal with this. And this is what we have right here. We have negative 4 minus lambda multiplied by that. Now minus 10, which gives us 10. And guys, when we come to this position, it shall be negative. And then we find, if we close there, that is this column and this row. Guys, our matrix will give us 0. And also this one will also give us 0. And so finally we shall have such kind of an equation, which when we do it, guys, we shall get a polynomial equation, which is right here. And when we now simplify the polynomial equation, guys, we are going to get this. Guys, after trial and error method, guys, we were able to find lambda 1 is equals to 3. So guys, you can put 3 here and see whether you get 0. So when we get 3, guys, now that forms a factor, which is lambda minus 3 is a factor. And using that factor, guys, we can come and get the other factors. Indeed, we are going to get our solution as a quadratic equation right here. And now, guys, from there, we need now to solve our quadratic equation. After we have divided our polynomial with one of the factor, guys, we get that quadratic equation. And that's what, guys, we are now going to solve in order for us to get the other factors. Guys, now solving the quadratic equation, we get these two factors. And the two factors gives us lambda 2 equals to negative 2, lambda 3 equals to negative 1. And so therefore, guys, our eigenvalues are lambda 1 equals to 3, lambda 2 equals to negative 2, and lambda 3 equals to 1. Guys, these are our eigenvalues. Guys, we now go ahead and find the eigenvectors corresponding to these eigenvalues. Guys, we can start with 3. Starting with 3, we come here and use this equation. This equation is A minus lambda 1 into bracket multiplied by this vector, this gives us 0. So guys, we now come to our matrix. And for our matrix we had, guys, we come and now replace for lambda 1. In the matrix that, guys, we were looking for lambda. And guys, that is in this matrix. Remember, we were looking for lambda in this matrix, and now we got one of the solution is 3. So that's what we are replacing. And by replacing, guys, this is what we are now going to find. After we have replaced with 3, we'll get this matrix. So guys, after we have gotten that matrix, and we have gotten that by replacing lambda 1 equals to 3, we shall have now this equation, which now we intend to equate that to 0. Equating that to 0, we can start with the first row. For 0, x, that is 0, then we have 2y1 plus 2y, 2z, this is 2z, 1, this gives us 0, and we also have this minus 7y1, we use that and that. Guys, we get 0. So finally, we shall have this last one, which is 5y1, gives us 0. And therefore, guys, our y1 is equals to 0. If y1 is equals to 0, we replace it here. Guys, this becomes 0. So negative 2z1 equals to 0. And therefore, z will also be equal to 0. Guys, for the value of x, it's actually free. It can take any value. And so therefore, guys, we now put the least value. That is positive value. And that is 1. So for the other values is 0 and 0. So guys, this is the corresponding factor. This is the eigenvector corresponding to eigenvalue 3. Guys, now we go to eigenvector corresponding to eigenvalue negative 2. So guys, we do the same. We replace for lambda 2 with negative 2. When we do that, this is what we get. And now when we use the equation, we will equate it to 0. By so doing, guys, we shall have this. We shall have 5x squared plus 2y squared plus, that is 2y2, 5x2 plus 2z2. First row, and that we get 0. Coming to the second row, we shall have negative 2 y2 plus negative 2 z2, and that's where it's here. Finally, we shall have 5 y2 plus 5z equals to 0. Having that, guys, as you can see, our y2 will be equal to z2 according to this equation. y2 is equals to negative z2. So guys, if y2 is 1, then z2 is going to be negative 1. And therefore, guys, we now come after that, use this equation now to get our x2. Remember here, we can replace 2y2 with negative 2z2. And that's what I have done right here. Because we are saying that z or y is equals to negative z2 as shown here. So I replace the y with negative z2. And when we do that, guys, we shall find that 5x2 is equals to 0, which tells us that x2 is also equal to 0. And so therefore, guys, this now we can say z, we can give it 1. So if we give it 1, this will become negative 1. And our x is 0. And so therefore, we have 0, negative 1, 1. Remember, these are just ratios. And so therefore, when we give 1 to y2, the z is going to be negative 1, or vice versa. If we give y2 to negative 1, z becomes 1, like this. And then we have x already, it is 0. Guys, now you can look for lambda 3. That is eigenvalues vectors corresponding to eigenvalue 1. Guys, please do that and see whether what you will get as your answer. Thank you for listening to me. Bye.